So now we're going to finish off our investigation of the different trig functions and what their graphs look like with tangent and cotangent. These are a bit different than the sine and cosine graphs, and it would be helpful for you to have your trig chart or a unit circle handy for reference on this. So first, let me remind you that we defined tangent of x as being equal to sine of x over cosine of x. So that was how we filled in the tangent column on our trig charts, was by taking the sine value and dividing by the cosine value. Well, this has a couple important implications for what our graph will look like. First one being that we can identify the x-intercepts by looking at wherever sine of x equals 0. So we are going to touch the x-axis at any of the places on the unit circle or the trig chart where the numerator equals 0 or sine equals 0. So that's going to happen at 0. And then if I set up these tick marks as being 2 lines equals pi over 2, then the next two would be pi, and then 3 pi over 2, etc. Then the next time it hits 0 is going to be at pi, and then it'll happen again at 2 pi, and 3 pi, and 4 pi, etc. And it also happens in the other direction, going to negative pi, negative 2 pi, etc. So wherever the sine of x column equals 0, those are going to create our x-intercepts, because 0 divided by anything is equal to 0. The next important values for our graph are when cosine of x is equal to 0. So if you look at the cosine of x column on your trig chart, anywhere that the denominator of a fraction equals 0 causes an undefined value. So those undefined values are what make asymptotes in our graph. So that means at pi over 2, we'll have an asymptote that the graph will approach but never touch. And the same thing happens in the negative direction, so negative pi over 2. Remember, you can find the negative radian measurements by going clockwise around the unit circle instead of going counterclockwise the way we have it labeled. So it happens at pi over 2, and then there's another place that happens at 3 pi over 2. And then same thing for the negative values, so negative 3 pi over 2. And then most of the other values aren't very nice numbers to have to deal with plugging in, but you should see that at pi over 4, the height ends up equaling 1. So let me mark my vertical scale as well. I'll do every other tick mark is equal to 1, so then 2 and 3, etc. So if you want to put those dots in there, you can, and then going in the opposite direction, you have negative 1. So basically, you end up with what kind of looks like the x cubed graph, essentially. You just have to be very careful about where the intercepts and the asymptotes especially are marked. And so then it does this shape again in each of these little sections that we plotted out. So this shape just occurs over and over and over again an infinite number of times going throughout the function. And if you want to be very careful about plotting more of the coordinates, like I said, you can still use the sine divided by cosine values. The problem is just that a lot of them come out to ugly numbers involving radicals. So the easiest ones to plot are the 0, the pi over 4, and the pi over 2 value, and then it starts over again. Now, one thing you'll notice about our graph is the period is a little bit different than what we had for sine and cosine. For sine and cosine, we said the period was 2 pi divided by b. Now we have exactly half of that length for the period. So what's happening is the entire shape of the graph is occurring within this length from negative pi over 2 to positive pi over 2. So that total horizontal distance is a length of pi, unless there's some kind of a stretch or a shift going on with the graph. So the standard is pi divided by b instead of 2 pi divided by b, like sine and cosine had. Now here's the cotangent graph. It's going to have a very similar shape with a couple minor differences. Now, since we're flipping the cosine and the sine value, we still have that same idea of identifying the intercepts and the vertical asymptotes, but now it's backwards. Now, wherever the cosine of x graph equals 0, we'll create an x-intercept. So I would start off by looking at that cosine column and thinking about where it touches the x-axis. And so if I set my scale the same way I did for the other one, which is what I usually use unless there's some kind of a stretch or a shift going on. So every other tick mark is half of pi, and vertically I'll still use the 1, 2, 3 for every other tick mark. So now cosine of x ends up hitting 0 at pi over 2. So this is going to be an x-intercept, and then it's going to happen again looking at the trig chart at 3 pi over 2, or on the negative side, so negative pi over 2, and then negative 3 pi over 2. And the places where sine of x is hitting 0, now that that's in the denominator, those values are going to create our asymptotes. So that actually happens right here on the y-axis. And then again, it happens a length of pi later. So this function does have the same period as tangent. It's still pi over b instead of 2 pi over b. And it happens in the negative direction as well. And this pattern will continue over and over and over again, however wide your graph is. So every length of pi, it should occur again. Now, the other important difference from tangent to cotangent is that this graph, instead of starting from the bottom left and going to the top right, this one flips that around. So now it's going to go from the top left to the bottom right. It's still going to look like that x cubed shape. It's just going to be upside down for it. So it's like it's been flipped around. And you can see exactly why that's happening if you want to actually plug in the x and the y values, or the sine and the cosine values, and make those fractions out of them, and then reduce them. Again, the only numbers that are really easy to plot usually are the pi over 4 and 3 pi over 4 values, though. So it's very easy to confuse some of the aspects of the tangent and the cotangent graphs. Make sure that your cotangent graph has the asymptote going through the origin and then lands a length of pi away, and it should be upside down for the x cubed shape. When you're comparing that to tangent, this one has the asymptotes straddling around either side of the y-axis, and the intercept is actually happening at x equals 0. And then the other important difference being the fact that this one is going from the bottom left to the top right. So this one looks just like the x cubed shape. This one looks like the x cubed shape upside down. That's all for your notes. That's all for the chapter. Everything else we'll be reviewing before the next test.